Bet you thought this was gonna hit me, didn't you?
No, I didn't. Using the diameter of a standard ball, I first calculated the height of the turbine. This piece was 2 meters and the whole tower was 15 of these pieces, which means it's 30 meters tall. The blade was roughly 45% of the height of the tower, which means the rotor diameter of the turbine is 27 meters. I then looked up a database of wind turbines using these sizes and found out the model of this tower is the Vestas V27. Then I reviewed the spec sheet and saw the blades spin at 43 RPM. So the angular velocity of the blade would be 43 times 2 times pi divided by 60, which is 4.5 radians per second. Since the ball hit the middle of the blade, that means the blade's velocity at the point of collision is half the blade's length times the angular velocity, which is 30.4. Now let's look at the initial velocity of the ball. After the kick, it took the ball 0.74 seconds to make contact with the midpoint of the blade, which is at a height of 24.75 meters. Doing some simple math, we can calculate the initial velocity of the ball to be 37. Deduct the speed drop because of gravity, we get 29.8. This would also be the ball speed on the y-axis after it gets hit. Then divide this by gravity and you would get the time it takes for the ball to reach its max height after the impact, which is 3 seconds at a total height of 70 meters above the ground. The time it takes for the ball to fall down is 3.8 seconds, which means the total time the ball is in the air is 6.8 seconds. Now on the x-axis, the speed of the ball would be the speed of the blade, which we calculated, times 1.6 because of the bounciness of the ball, or 48.6 meters per second. And then we simply just multiply the time and speed to find out the ball fell down 331 meters from the wind turbine. I know you recorded your video in your home in Malibu, but the problem is the nearest wind turbine to you is over 100 kilometers away. So no, I never thought the ball was gonna hit you.